Welcome to a completely new and exciting section. Introduction to Streamlit. Streamlit is a modern, open-source Python framework that allows data scientists and machine learning engineers to create beautiful, interactive web applications for their data projects with minimal effort and without needing any web development experience. 1. What is Streamlit? Streamlit is specifically designed to turn data scripts into shareable web apps. Instead of writing separate code for the backend logic and the front-end user interface, Streamlit lets you write everything in pure Python. It handles the complex plumbing of web development for you, allowing you to focus purely on your data and models. 2. Why use Streamlit? Streamlit solves the problem of sharing dynamic data results. Historically, if a data scientist wanted to let a colleague interact with a model or filter a large dataset, they had to build a full web application using complex frameworks like Flask or Django, requiring knowledge of HTML, CSS, and JavaScript. Streamlit replaces all of that with simple Python function calls. 3. The execution model data flow. A key concept in Streamlit is its unique data flow. Whenever a user interacts with a widget, like a slider or a button, Streamlit automatically reruns the entire Python script from top to bottom. This reactive, single-page execution model is what makes it so simple. It is Python first. The code you write is the app you get. To summarize, Streamlit is designed for speed and simplicity. Our next lecture 41.02, Project Setup. See you there. Welcome back. Before we can start building interactive apps, we need to set up our environment. This lecture covers the essential steps: installing the Streamlit library and learning the specific command required to run a Streamlit application. 1. Installation using pip3. Since Streamlit is a pure Python library, installation is straightforward using the pip3 package manager. Simply open your terminal or command prompt and run pip3 install Streamlit. This command fetches and installs the library and all its dependencies. 2. Creating the app file. All Streamlit applications are simply Python files. Create a new file. Let's call it first_app.py. Inside, we import the library, typically aliased as stk. Then we call a simple function like st.title to display text, which will serve as the initial content of our application. Three. Running the Streamlit app. To launch the application, you must use the Streamlit run command followed by the name of your Python script. Execute this command in the same directory where your script is saved. Streamlit will automatically open a new tab in your web browser, usually at a local address like localhost port 8501, displaying your running application. 4. The Streamlit local URL. When the app launches, the terminal will display two URLs: the local URL for access on your machine, and the network URL for others on the same network. Your app will be running at one of these addresses, ready for interaction. To summarize, the setup is quick and simple. Our next lecture 41.03, Hello Streamlit. See you there. Welcome back. Now that our project is set up, let's explore the core function Streamlit provides for displaying content. In this lecture, we will learn how to write titles, headers, standard text, and data using just a few simple Streamlit commands. 1. Writing the Streamlit script. We start a new file, app.py, and import Streamlit as stl. We also import pandas, as we will use it soon to demonstrate how Streamlit handles data. 2. Displaying titles and headers. To add visual structure, Streamlit provides dedicated functions. st.title displays the largest, most prominent text for the page title. st.header and st.subheader display section headings, which are rendered with different font sizes and boldness. 3. Standard text and data. The most flexible function is st.write. If you pass it a string, it displays text. More importantly, if you pass it a complex object like a pandas data frame, it automatically renders it in an attractive, interactive table format, demonstrating Streamlit's data focus. 4. Using Markdown. For fine-grained control over text formatting, the st.markdown function accepts Markdown syntax. This is highly useful for integrating bolding, italics, lists, and links without complex HTML. The combination of st.write and st.markdown covers almost all of your content display needs. To summarize, these simple commands are the building blocks of any Streamlit app. Our next lecture 41.04, Calculator. See you there. Welcome back. We are moving beyond displaying static content to creating interactive applications. In this lecture, we will build a simple two-number calculator to demonstrate how to capture user input using Streamlit widgets and how the framework's reactive execution model makes interaction seamless. 1. Capturing numerical input. We start with the st.number_input widget. This is designed for numerical values and returns the entered value, which we store in number 1 and number 2. When the user changes the value in the input box, Streamlit detects the change, and as we learned, it reruns the entire script, updating the variable with the new value. 2. Selecting the operation. Next, we use st.selectBox to let the user choose the arithmetic operation. This widget displays a drop-down list. The selected option, such as add, is stored as a string in the operation variable. Changing the selection also triggers a script rerun. 3. Performing the calculation and output. Since the entire script runs every time an input changes, we simply place our calculation logic after the input widgets. We use standard if-else conditions based on the selected operation. When the script runs, the calculation is performed using the latest values of number 1 and number 2. Finally, we use st.success to display the result prominently, providing immediate feedback to the user. To summarize, Streamlit handles the web complexity, you just write the Python logic. Our next lecture 41.05. Use DataFrames. See you there. Welcome back. Streamlit is a powerful tool for data scientists, and a core reason for that is its seamless integration with Pandas DataFrames. In this lecture, we explore the primary ways Streamlit displays tabular data, differentiating between interactive and static table visualization. 1. Creating sample data. We first set up a Pandas data frame using number.py to generate some random numbers. This data frame, df, represents the kind of structured, tabular data often analyzed in data science projects. We want to display this data in our Streamlit app. Two, interactive display, st.dataframe. The primary function for displaying dataframe s is st.dataframe. This function renders the data in a dynamic table. Users can typically scroll through large datasets, and depending on the Streamlit version and settings, they might be able to sort or resize columns. This function is preferred for presenting large datasets that users need to explore. Three, static display, st.table. In contrast, st.table displays data statically. It cannot scroll or interact. This function is optimized for displaying smaller datasets like configuration summaries or the head or tail of a data frame because it loads the entire dataset into the document object model or DOM at once. To summarize, choose data frame for big data exploration and table for small, fixed displays. Our next lecture 41.06, Feedback App. See you there. Welcome to our final lecture on the basics of Streamlit. We have covered displaying data and simple input. Now we will build a functional user feedback application, demonstrating how to use buttons to trigger actions and how to handle form submission in Streamlit. 1. Designing the input form. We use two different input widgets. First, st.slider is excellent for capturing a numerical range, here used for the user's rating from 1 to 5. Second, st.text_area is used for long, multi-line text input, perfect for comments. Both these actions automatically update their respective Python variables. Two, the submission button. We add an st.button. Crucially, when this button is clicked, it returns true and triggers the entire script to rerun. We store this Boolean result in the submitted variable. This is how we know the user is ready to finalize their input. 3. Handling submission logic. We wrap our form processing logic in an if submitted block. First, we perform a validation check, ensuring the comment length meets our minimum requirement. If the validation fails, we display an error using st.error. If successful, we display a confirmation message using st.success, including the captured data. In a real-world application, this is where your code would save the data to a file or database. To summarize, the combination of input widgets and reactive execution allows us to build powerful, full-featured applications easily. This concludes our introduction to Streamlit. Next, we will transition into data validation with the powerful Pydantic library. Our next section is using Pydantic for data validation, starting with Lecture 42.01. Introduction. See you there.